So we're going to 2. Mad props. Properties of logarithms. Warm up. Identify the property of the powers associated with each example. 1. 2 to the 5th times 2 squared equals 2 to the 7th. That's the product rule of powers. 2. 2 to the first power equals 2. That's the identity power rule. 3. 2 to the 0 equals 1. That's the zero power rule. 4. 2 to the 14th divided by 2 to the 5th equals 2 to the 9th. That's the quotient rule of powers. Let's take a look at the next page. Getting started. Show what you know. You have studied the properties of powers in previous lessons and in previous courses. Let's recall some of these properties. 1. Rewrite each expression. Select the properties you use to justify each step in your process. Okay. A uses the product rule of powers. Okay. So to simplify that, first off, 4 times 6 is 24. And then we have x to the 5th, x squared, x, technically that's to the first power. And then we have y to the 6th and y to the 1st. Okay. So then that's 24. X to the 5th plus 2 plus 1 times y to the 6th plus 1, which simplifies to be 24. 5 plus 2 plus 1 is 8. And then 6 plus 1 is 7. All right. Let's take a look at B. B uses the product rule of powers, quotient rule of powers, and the zero power rule. Okay. So first off, we have 42 divided by 6. And then we have m to the 5th, m to the 4th, n cubed, n squared, divided by m to the 6th and to the 5th. All right, 42 divided by 6 is 7. And then we have m to the 5 plus 4 minus 6, n to the 3 plus 2 minus 5, which equals 7 times m to the 9 minus 6, which is 3. And then n to the 3 plus 2 minus 5 is 0, which equals 7 times m cubed. All right, let's take a look at C, which uses the power to a power rule. Okay, so this equals negative 3 to the 5th, x to the 7 times 5, y to the 3 times 5, which equals negative 3 to the 5th power is negative 243. X 7 times 5 is 35. And y 3 times 5 is 15. All right, go ahead and finish it up. All right, let's take a look at the next page. All right, activity 2.1, properties of logarithms. Now let's consider how the logarithmic rules and properties correspond to various exponent rules and properties that you already know. 1. Let's consider the zero property of powers to develop a corresponding logarithmic property. A. Write a sentence to summarize the zero property of powers b to the 0 power equals 1. Any base raised to the 0 power equals 1. B. Write the zero property of powers in logarithmic form. This is a corresponding logarithmic property called the zero property of logarithm. Log base b of 1 equals 0. C. State the zero property of logarithms in words. The logarithm of 1 with any base is always equal to 0. 2. Let's consider the base raised to a power of 1 rule that says that any number raised to a power of 1 is equal to the base. Write an exponential equation to represent this rule. Use b as a base. B to the 1 equals b. B. Write your exponential equation from part A in logarithmic form. Log base b of b equals 1. C. State the logarithmic relationship in words. When the base and the argument are equal to the logarithm is always equal to 1. All right, let's take a look at the next page. 3. Let's consider the product rule of powers to derive a corresponding logarithmic property. A. Write a sentence to summarize the product rule of powers. B to the m times b to the n equals b to the m plus n. When multiplying powers with the same base, you add the exponents. B. Analyze the steps that begin with the product rule of powers to derive the corresponding logarithmic property, called the product rule of logarithms. Complete the last line of the diagram. All right, go ahead and read over the diagram. All right, let's take a look at C. State the product rule of logarithms in words. The logarithm of a product is equal to the sum of the logarithms of the factors. All right, let's take a look at the next page. 4. Let's consider the quotient rule of powers to derive a corresponding logarithmic property. A. Write a sentence to summarize the quotient rule of powers. B to the m divided by b to the n equals b to the m minus n, if b does not equal 0. When dividing powers with the same base, you subtract the exponents. B. Complete the steps that begin with the quotient rule of powers to derive a corresponding logarithmic property called the quotient rule of logarithms. Go ahead and read over that and complete the steps. All right, let's take a look at C. Summarize the quotient rule of logarithms in words. The logarithm of a quotient is equal to the difference of the logarithm of the dividend and the logarithm of the divisor. Let's take a look at the next page. 5. Let's consider the power to a power rule to derive a corresponding logarithmic property. A. Write a sentence to summarize the power to a power rule. B to the m to the n equals b to the m times n. To simplify a power to a power, keep the base and multiply the exponents. B. Complete the steps that begin with the power to a power rule to derive a corresponding logarithm property called the power rule of logarithms. All right, go ahead and read that over and complete the steps. C. State the power rule of logarithms in words. The logarithm of a power is equal to the product of the exponent and the logarithm of the base. All right, let's take a look at the next page. Activity 2.2. Using properties of logarithms to rewrite expressions. You can use the properties of logarithms to rewrite and combine logarithmic expressions. 1. Use the properties of logarithms to rewrite each logarithmic expression in an expanded form. Okay, A is written as log base 4 of 6 plus log base 4 of x to the 5th, which expands to log base 4 of 6 plus 5 times log base 4 of x. All right, let's take a look at B. All right, this becomes log base 7 of 3y to the 4th. Oh, I'm sorry. Log base 7 of 3 plus log base 7 of y to the 4th minus log base 7 of x cubed, which equals log base 7 of 3 plus 4 times log base 7 of y minus 3 times log base 7 of x. All right, go ahead and finish it up. All right, C becomes ln of 3 plus ln of x plus ln of y cubed, which equals ln of 3 plus ln of x plus 3 ln of y. Let's take a look at 2. Use the properties of logarithm to rewrite each algorithmic expression as a single logarithm. All right, so this becomes log base 2 of 10x. All right. B. This becomes log base 10 of 12 to the 4th minus log base 10 of 2 to the 4th which equals log base 10 of 12 to the 4th divided by 2 to the 4th, which equals log base 10 of, let's go and use Desmos to get that number. So 12 to the 4th divided by 2 to the 4th is 1296. All right, let's take a look at C. All right, so this becomes 3 ln of 3 minus 3 ln of x plus ln of x minus ln of 9, which becomes ln of 3 cubed minus ln of x cubed plus ln of x minus ln of 9. Which becomes ln of 27 minus ln of x cubed plus ln of x minus ln of 9 equals ln of 27 divided by x cubed times x divided by 9. All right, go ahead and finish that up. All right, let's take a look at the next page. All right, go ahead and mark out 3A, B, and C. 4. Identify the property logarithm associated with each example. A is a product rule of logarithms. B is an example of zero property of logarithms. C is an example of identity power rule. D is an example of the quotient rule of logarithms. All right. Minor typo we're going to fix now is B and C are wrong. Let me fix that. This is actually the identity power rule. And this is the zero power rule. I apologize for the mistake, but it is corrected now. All right, with that fixed, let's move on to the next page. Talk to talk. Organize and mathematize. You have derived different properties of logarithms. 1. Complete the table to define each exponential and logarithmic property verbally and symbolically. Provide examples for each group. All right, go ahead and complete the exponential property and logarithmic property portion of the table. All right, go ahead and complete the base raised to a power of 1 and a logarithm with the same base and argument portion of the table. All right, let's take a look at the next page. All right, go ahead and complete the exponential property and logarithmic property portion of the table. All right, go ahead and complete the quotient rule of powers and the quotient rule of logarithms portion of the table. All right, go ahead and complete the power to a power rule and power rule of logarithms portion of the table. All right, let's take a look at the next page. The student works 1A, 1B, 1C, 1D, 2A, 2B, 2C, 2D, 4, and 5. All right, let's take a look at the next page. The student works 1A, 1B, 1C, 1D, 2, and 4. All right, go ahead and start working on your assignment and have a wonderful Wildcat day.